choosing the best charger for your RC applications can be a bit of a challenging process. Today we have the TP610 series chargers on the bench, the 610C AC/DC with built-in power supply, and also the TP610 DC only. Both have DC input, but the 610C AC/DC can handle 100 to 240 volts AC with its built-in power supply. Even looking at Thunder Power's lineup, you have the 610 series, the 1430C, and the 820CD. Looking at which one's going to fit your needs most effectively is the key. And then ultimately there's the hobby budget. The DC only version is right at this time is $99, and for an extra 20 bucks you can get the AC/DC version, which gives you the flexibility of charging on the bench. But there's a lot more going on with the 610 series than just two different available options. So let's take a look at some of the specs and then we'll move to the bench. The 610 series can handle 11 to 18 volts DC input with 10 amp maximum charge rates on the output side. It'll also handle 25 memory profiles for each battery type, so you can quickly recall and initiate charge cycles. This is a multi-chemistry charger handling a lithium technology, lithium polymer, and also lithium iron phosphate, also known as A123 or life cells, at 1 to 6 cell counts. It'll also handle nickel metal hydride and nickel cadmium batteries at 1 to 14 cells, and PB or sealed lead acid batteries in 6 volt, 12 volt, and 24 volt configurations. The charge current is adjustable from a quarter amp up to 10 amps. It'll handle up to 9 discharge charge cycles for nickel batteries. The discharge rate is 50 milliamp to 1 amp. And the charge maximum output for all chemistries is 80 watts. 610 also has some unique capabilities like competition car mode charging. So let's head over to the bench and get familiar with its connections and programming. Okay, so we're going to use our TP610C AC/DC for demonstration today. Again, same head unit as the DC-only version. The only difference being from a port perspective is that this has the built-in power supply, so of course it has the AC plug, and we've got our AC plug right here. Looking at the front of the unit, we've got our select and mode button, our enter and stop button, and then increase and decrease our displays up here. And then they do give you some handy references to what your capacity and capabilities are, including your input. So when you're out in the field, you don't have to look anything up. You can pretty much see what the capabilities are on the charger right from the front panel. On the left-hand side, we have our DC input. Now again, if you want to get the most out of this charger, the AC/DC version, you're going to have to use, or you're going to want to use an external DC power supply, like this one here. I have an 18 amp. This is the most this can put out is 80 watts. So in any configuration, 10 amps is the maximum output, and that's possible on 2S or 1S batteries. And then of course that amperage decreases relative to the voltage and the wattage calculation. But 10 amps max I can put out. 18 certainly covers it and gives me some headroom, which is always a good thing. As temperatures increase out in the field, power supplies and charging units will lose some of their ability to charge, the rates they can charge at. As the resistance increases, as that heat increases. So having a little bit overhead on your power supply is always a good thing. Like if I were to pick a power supply out specifically for this, I'd probably get a 12 amp or a 15 amp power supply to know that I've always got the TP610C covered for its charging capabilities. So DC input on the left-hand side. On the right-hand side, our power plug we just talked about. We've got two banana jacks, standard banana jacks for positive, negative and positive input or output to our main battery leads. And then we also have our charging jack, which is beside that. That accommodates the included charging balancing board. So our balancing port is right beside the firmware upgrade port. Now this requires a PGM-V2 cable. Thunder Power no longer sells that cable. They've moved on to USB or mini USB interfaces for their firmware updates. But you can still find this cable out there in some places, and you can purchase it and connect and download the firmware directly from Thunder Power and do your own updates. Or they have a program where you can send this unit in, either the DC or the AC DC version in. You cover the shipping inbound, they'll do the firmware update for you, bring up to the latest version, and then cover the shipping back. So it's a pretty good deal, and it's always good to have the latest firmware versions for your chargers. Specifically with the 610C, when they moved to version 6.0 of the firmware, they added that competition car mode charging option in there. So if you have anything prior to the 6.0 firmware and you want to take advantage of some of those latest features, you're going to want to send it in and get it updated. Looking at the balancing board, as we'd mentioned, it just simply plugs into the side, and it has accommodations for the TP packs, the JST-XH or Thunder Power Flight Power packs. Now you'll see that listed a lot of times as TP-FP or JST-XH. So you have two different banks to work with, and again, going up to our 6S and our 6S pack there, which you'd use the 2.3 and the 6S on those 6L configurations. So we have a lot of flexibility on our balancing board. They do include charging leads. These are banana jacks, unterminated on the other end. We went ahead and put a Dean's Ultra plug on there since the packs we're going to be using today for demonstration have Dean's on them. We just put a Dean's on this to accommodate it as well. So you can solder on your own connector for whatever you need for your battery type. And then the order of operations is, we're going to do a couple things at once here. We're going to power on the unit. It's going to display the firmware version so you can see that. So you can check your own firmware version. But always power up your charger first. And there's our firmware being displayed, version 6.0. And then you connect your battery. And that usually goes balancing lead first. And this is a 2-cell pack, 7.4 volts. We're going to put in the 2-3S connection on the balancing board, and then we connect our main pack lead. Now the TP610 does not balance or does not charge through the balancing leads for these really high charge rates it's capable of. It charges through the main pack leads and then does a discharge process to the balancing board to keep everything level. So you're going to need both of these connected through the charge process as well as the charge and discharge process. You always want to have both your leads connected. So we're sitting on the main menu. The first thing it does is we left it in LiPo, so it's LiPo charge and it's saying select. Now using our increase decrease, we can select memory slots. Remember we said we can have 25 on each cell chemistry, so I can have 25 different memories set up for LiPo, 25 for life, and so on. I can go through at this point, and I have to hit it again because it timed out on me. I can go through and choose any of those stored memories, and these are just some random ones I threw in there. The cool thing about this, which I really like a lot, is the memory storage is really easy. You don't have to go into a separate screen and save data or load data or anything like that. All you do is simply move on the slot that you want, and you set it up for it. You hit Enter Stop, and that'll allow you to go into the number of cells and series on the pack. In this case, we're using 2S. We use this big old 5,000 milliamp as an example. So I can go through and say, all right, this is a 6S pack. And then from the current perspective, this is actually the amperage, the rate at which you're going to charge the battery. You can find that on the batteries. Thunder Power makes it pretty easy on the front of theirs. It makes it very easy. It'll tell you right at the bottom. Charge is 6L, 12C, 60 amp max or may cause fire. Now if we look at our 2S pack, this is a 65C as well. This is our new G8 chemistry. This is the G6 predecessor chemistry at 65C discharge. It says charges 2-cell 12C. Same charge rate as the 70 now, 63.6 amps. So that's the max rate we can charge this pack. So you're going to go through and adjust your charge rate based on what your pack tells you can charge it. You can also always charge at 1C. It doesn't hurt anything to charge at 1C on a LiPo pack. And you'll hear that C referred to a lot. We can figure out C pretty easily. We know 70C on the discharge side, but the thing we're really curious about is the charge rate. What is 1C for this pack? So if it's a 5,000 milliamp pack, you take the capacity, the milliamperage capacity, you divide it by 1,000, and that's going to give you 5. So 1C charge rates for this pack is 5 amps. Take our 5,300 milliamp, of course, using the same formula, 5,300 divided by 1,000, 5.3 amps is for this pack, is 1C. So it goes off the capacity is what it really cares about. Even when we look at our tiny little 250 milliamp 25C here, 1C for this battery is 250 divided by 1,000, of course, is 0.25, so it's a quarter of an amp. So getting ourselves set up to go ahead and charge, we'll set the battery aside here. We've got our battery connected to the balancing board. We've got it connected through the main leads. At this point, we do have the option of checking where the cell pack is, or the cell voltage is right now. It's pretty easy to do. Regardless of memory we're on, we'll go ahead and move back down to memory 1 here. So we're starting off at the base screen. What we can do is go through and set our pack up. It's a 2S pack. Right now the current's set for 10 amp. This will certainly handle it. It's a 2-cell, 7.4 volt. You can do charging up to 5C in this as well, which if you notice in the battery is 27 amps max. Well, our charger can never put out that much current, so we're fine at 10 amps. We'll go ahead and run it up to the maximum, which will bring on another point in a second. Sitting here on the main screen, we've pretty much just set up this charger to charge this pack. This is really all you have to do out of the box to get a charge started, an effective LiPo charge started, because the settings are all defaulted, which are all safe within industry standards. If we want to get in further into the LiPo configuration and the options, all we do is hit our select mode key for 2 seconds. And that's going to take us into our battery type as LiPo. We can increase now to different cell chemistries. We're going to leave it on LiPo. And then we'll go ahead and select. That's going to take us to the next option under LiPo. And this is the charge option. This is the mode we want to charge in. Do we want to fast charge it? Do we want to do a 100% charge? Do we want a 95% charge? A 50% storage charge? And then back to fast charge. We additionally have the option of the competition car mode, which is on the next screen. We'll show you that. Let's talk about these charge modes real quick. So we're starting off at 100% charge. That's going to take the cells to 4.2 volts per cell. That's a standard LiPo charge. Very, very standard, normal for all chargers. You're going to look at a cutoff, a max charge cutoff on a LiPo cell of 4.2 volts per cell. So that's 100% charge. Good for normal everyday use. It's going to top the battery off to industry standard safe levels of 100%, and you're off and going. Now everything you do on the TP610C is a balanced charge, unless you're doing a one-cell pack. Then of course there's no need for balancing since there's only a single cell. So we'll move down. 95% charge is going to take it to 95% of the cell voltage. A little faster way to get things finished out. It's going to go through the CCCV process as well, so it'll go through the typical charge process, but stop at 95%. So it'll turn the pack around a little bit faster for you. Even faster option is, I'll move down, fast charge. Fast charge is going to take the pack to 80 to 85% of its capacity, and it's going to pretty much ignore CV. Now, typical LiPo charging happens in two phases. The first part of the charge process is constant current, and then the second part is constant voltage. We've talked about this before in some of our other clinics, and we have some additional information on the website, so if you really want to read into that and understand CCCV. But essentially, it's at CC, it's going to drive it through the stated current rates, and as it gets towards the 85%, 80-85% portion of the battery charge, it's going to say, all right, now I need to go to constant voltage. It's going to reduce the charge rate, the amperage rate, and it's going to monitor the voltage closely. And you'll watch that charge rate, the current continually decrease until it tops off the cells. The reason being is you don't want to heat up LiPo chemistry when it's charging. It should always stay cool while it's charging. And the other thing is too is resistance. Internal resistance increases on the cell, on the pack, as you reach maximum charge. So to be able to allow it to top off and gradually hit that capacity of the cell without causing any overheating issues or too much resistance, it starts lowering the rate at which it's charging. So that's what the CCCV is. That fast charge is going to skip the CV portion and pretty much stop once it says, all right, I'm at 80 or 85%. I don't need to go any further, and your battery is good enough to use. So we go back to the storage charge was the other thing we skipped. Here it is, 50% storage. Now something interesting about the 610C is when you go to storage charge, a lot of the other chargers out there, including the other ThunderPower chargers, have a storage setting on them. 50% storage is going to take the cells to about 3.85 volts per cell, which is a classic 50% voltage level. In fact, when you buy a brand new pack, they typically have, they start off from the factory at storage voltages, so they may ship out of the factory at 3.85 volts. That allows, it's a very safe voltage. It's not too high that'll cause any sort of swelling of the cells over time, so it's a good, when you store LiPo at absolute maximum, you really risk puffing the cells out or swelling the cells, which can certainly decrease capacity or performance off of the battery itself. So you always want to bring those things down to storage voltage when they're going to be setting for a while. I say a while, essentially after the day's running or after the day's flights, I'll bring all my packs down to 3.85. I just throw it on the charger, let it do its thing, and I know my packs can set then for 6 months, 9 months up to a year, no problem, because the self-discharge rate's so low on lithium chemistry that they'll be in good shape when I want to bring them out and use them again. So this storage charge is for that purpose. Now something, like I said, about the 610, unique to it is that it does not have the ability to draw the pack down to 50%. The other chargers do. You can pull them down to 50% storage, or you can charge them up to 50% storage. The 610C is going to be looking for below storage values. In fact, it kind of tops off at about 3.7 volts. It needs to be around 3.7 volts to take it up to the 3.85. So it's kind of a fine line on its storage capabilities. If your pack's pretty charged from the field, you're going to want to discharge it first down to. So you only use storage if you need to bring it up to 50% storage. You use discharge if you want to bring it down to 50% storage, and you just set that in a cell voltage cutoff of 3.85 and you're ready to go. So that covers the different modes. Now there is another mode we can go into. If we choose it, this is where we choose our charge option. So we'll go ahead and leave it on a full charge. 100%. I passed it up. There it is. We'll continue through the menu on our LiPo options. This is where competition car mode kicks in. Competition car mode will take the battery up to 4.22 volts per cell. Now this is, again, recognized by most racing organizations out there as a safe full charge levels. So guys that are out there racing, they want to get the absolute maximum life or performance out of their cell for that heat. They're going to go ahead and take it to put competition car mode on. It's going to drive that charge process up to 4.22 volts per cell. That's as high as you ever want to take it. That's a safe maximum charge range. So competition car mode can be off or on. Now if you turn it on, it overrides the other LCOs or LiPo charge options you set. So if you set it to 50% storage or full or 95 or fast or any of those other options, it ignores them as soon as you turn on competition car mode. It's going to drive it to 4.22 volts per cell. And so if you get a little confused, you wonder why it's not doing what you want it to do, make sure you've got the competition car mode either on or off intentionally. So we're going to go ahead and leave it off and continue through our options for lipochemistry. Discharge option, cutoff voltage 3.3 volts per cell. That's very safe considering that when you're under a discharge, it's technically a load. Under no load, you can take a LiPo down around 3 volts and you're pretty safe. The absolute low is down below that, but you never want to take your cells down too low and risk self-discharge below minimum charge levels. So that is adjustable. You can take that up or down depending on what you want to do, and it'll go down at the minimum of 3.0 volts, which again is the lowest you want to take a LiPo in a load scenario or no load scenario is 3 volts. But you can adjust that, so we'll leave it as a default. We'll move on. This is lithium polymer and lithium iron phosphate, or LF init charge timeout is 10 minutes. Now the init charge is what happens as soon as we go to start a charge process. The 610C is intelligent. It's going to look at the minimum charge levels. So if our pack has been over discharged and it's below levels, it's going to go to a very low initialization mode to make sure that our cells are balanced out and also we're at minimum safe starting levels. In addition to the init charge, the 610C also has the capability to do battery recovery. Now battery recovery is really for advanced users. We don't want to get into it too specifically, but if you fire up a charge process with your battery and it gives you a warning that your voltage is too low, it's going to ask you if you want to go into a recovery mode. There's a lot of things to take into consideration. Has the battery been damaged? Is there any visible signs of problems? Is there any puffing versus swelling? And there's a big difference between the two of them. So you're going to want to make sure you're very comfortable with recovering a LiPo before you go into that recovery mode, but it does have the capability within the 610C. So we can set our init charge timeout. This is where it immediately looks at the cells, does a quick balance out, makes sure it's at acceptable minimum values, and then starts the charge process. So it's very common when you fire up your charge on the 610 to see it kind of hang out there on that init charge for a second or so, and then start the charge process. We can give it a timeout though. If it's taken too long to try to balance those cells, it could be indicative of a problem. The default's set to 10 minutes. We can drop that down even further, or we can, of course, take that up even higher. So leaving it at 10 is a nice safe number. Continuing through our options, beeper option, this is just for the key beeper. We can turn it off or on, which is kind of nice. You know, it gets nice and quiet then. But input power option, now this is a low voltage cutoff. If you're running on the internal power supply and things are getting pretty toasty, you're running with the AC, you know, you can drop that down below that level. And in fact, if you're getting a lot of input voltage errors on warm days when you're trying to charge off the power, so the internal power supply, you can drop that down to 10. It's set at 11 right now for a reason, and that is if you're charging off your automotive battery, you don't want your charger to inadvertently keep charging and doing its thing all day and driving your automotive battery down below where you can't even start up the car anymore or the truck. So this low voltage cutoff is set to 11 volts, which should give you in most cases, most all cases, enough juice left in your automotive battery to still start your vehicle and go on about your way. So that's the reason for the low voltage cutoff. You can always raise that up to 12 volts, or you can lower that all the way down to 10 volts. Again, 11 volt for battery charging off the DC input, and if you're running in hot conditions and you're getting low voltage input errors, you can always drop that down, or if you're running off the internal power supply. If you pretty much charge off your internal, you can drop that all the way down to 10 and you're fine. It won't be a problem at all. Okay, continuing on, system timeout, max time. Now this is the charge time. So when you start a charge process, it's going to be balancing cells, it's going to be doing its thing. If you're doing nickel metal hydride or nickel cadmium, you've got, you know, charge to discharge cycles that are going on. You can set this total process timer here. And right now by default it's set to 5 hour. You can raise or lower that as well. Now when I'm running LiPos, I can run my LiPo cutoff, my max time down lower than that because it's a very consistent process, and I'm not doing charge-discharge cycles like I would with a nickel battery. But if you get into lead acid or nickel, you may want to bump that up a little bit if you have a lot of cycling going on. And we go back to battery type. This is where, again, where we can choose. As you go into the different chemistries, you can choose the different settings for that chemistry. So battery type nickel cadmium, when we go into that, we have our delta V, which is our delta voltage. And what that comes down to is on NiCads, 5 millivolts is pretty standard. You can raise that for less sensitivity, or you can lower that for greater sensitivity. 5 millivolts is the lowest it's allowed to go, and it'll go all the way up to 30 millivolts. So you've got a pretty good range to work with. I usually start mine off around 5 millivolts. It really depends on the battery. You want to talk to your battery manufacturer, check out the specs, or talk to some of your buddies and find out what they're getting off of their packs for the best delta V setting. And all this does is looks at the voltage turn as you charge up a nickel chemistry battery. It's going to reach peak, and it's actually going to start going in the opposite direction. You'll lose voltage as you reach maximum and go beyond it. In fact, typically you want to take it right to that max, and as soon as it starts to dip, it's looking for a 5 millivolt variation between that full charge and then that discharge process, and that's when it cuts off maximum charge. So that's what that's all about. Lower number, greater sensitivity; higher number, lower sensitivity, more charge into the battery. So if you're getting a false cutoff on your battery and you're just not getting it up to maximum, you may want to raise that number a little bit until you monitor your temperature. A lot of people charge nickel cadmiums or nickel metal hydride chemistry based on temperature as well as a voltage cutoff. So once it starts getting pretty warm, not hot but pretty warm, you know you're getting right at the peak of that cell, and it should be about the time it cuts off. So you can adjust it accordingly. We can continue on. Again, you got the beeper option, input power option, system timeout, again max timer. And now we go to the cycle data. Cycle 1, you can scroll through the different cycles. This will keep memory of the last cycle that you put your battery chemistry through, and you can see what your discharge and what your charge time, capacity or milliamperage was for each of those cycles as you list them out or as you set them up. Continuing on, battery type, we go back to nickel metal hydride. It's going to have all the same settings as nickel cadmium and options. Battery type, lead acid. If we go into a lead acid type battery, we're going to have our charge top off, which you're going to want to verify on your battery manufacturer what the best charge top off voltage is for your lead acid battery. You can adjust that, of course. We'll continue through beeper option, input power option, system timeout, and then back to battery type. Life, again, it's going to have all the same options as LiPo, with the exception of we go through and choose our charge option here, but we'll continue past that. Competition car mode, it does support for life, and then there's the life discharge cutoff, and then also the init charge timeout on the front end, our beeper option, our input power option. So it automatically adjusts for the different cell chemistry's voltage, so you don't have to worry about that as you do have to on some chargers. So we're back to the beginning. Let's go ahead and go to LiPo, and we'll go ahead and select that chemistry. We'll choose our 100% charge option. We'll go ahead and hold down our select mode to get out of that. We're at that lower level menu right now. By holding this down for a couple seconds, it's going to take us back to our main screen where we execute a charge, choose the memory options, and things like that. So as we go through, hold this down, okay? Now what you can also do here is this is how you enter into your discharge level. So you can do all your charge settings and choose your charge mode, or if from just this main screen you can hit the select mode. It's going to take us to our discharge option, 2S pack, and it's going to look at our discharge amperage rate. We can adjust that as well. So just out of the chute, we can change what the actual discharge rate is. That's adjustable on this particular model all the way up to 1 amp. And on the bottom side is 0.10, a tenth of an amp. So this is where we would also set our discharge, where we would set our discharge cutoff back at that per cell voltage back in the main menu. But this is where we can select it. If we hit it one more time, it's going to take us into our internal balancer. It's going to go ahead and read the pack we have. So right from the main screen, and we can look at that again from startup. Say you're sitting there and you haven't done anything with the pack yet. We're going to go ahead and plug in the charger from scratch, because now we're going to go through the charging process. We'll go ahead and hold down our select mode button, or press it once. It's going to take us to the discharge option. Press it again. It'll take us to our checking internal balancer. So with the main lead connected and with the balancing board connected, we can now see what our current pack voltage is setting at and how out of balance it is. So it says cell number 1, 2, 3, 4, 5, 6. There's a 0 wherever there's a cell present and an X. So the first level of diagnostics you can do when you hook a pack up is make sure that you're getting the right number of cells back. So if I had this 6S pack connected and I was getting this kind of feedback where I only showed 2 cells present, I got a problem either with my balancing board connection or with my battery itself, and I've got an issue where it isn't registering the other cells. In this case, we've got a 2S, it's registering 2 cells here, so that's fine. Balance status shows those 2 connected. We can go up through it and it's going to show a cell low and cell high. Our highest cell voltage that's registering is 3.804 volts on cell 2, and the cell lowest one is 3.795. If we hit up again, it also registers how many cells are in a pack. Then we're going to go ahead, and it shows the variance as well. It's 0.009 volts of variance, which is fine. That's actually very imbalanced. We'll go up one more and we can see the actual cells themselves. Cell 1 is registering 3.795 volts, 2 is 3.804. So giving us quick, easy access to the information on our battery prior to starting a charge and receiving an error. It's also a good way to verify, too, after you've done a run, how in balance your pack is. It's always nice to see how out of balance your pack becomes after a heavy discharge during either a track heat or flying at the field. You come back down and you've discharged your battery to cutoff and you see a massive variance. You want to keep an eye on that and make sure you don't run into any situations where you start seeing even more out of variance. If you do, it may be a problem or early indication of a problem with your battery, and that's why it's good information to know before a problem occurs. So we can hit our select mode button again. It's going to take us back to the main screen. This thing's ready to go. 2S pack. The charge current is set to 10 amps, which is certainly within the capabilities of this battery's charge rates. So we're going to go ahead and hold down the enter key. It's going to execute the charge. You're going to see it doing checking pack voltage. It's also going through and telling you connected internal balancer, 2 cell, and the out of balance. It's now initializing the charge at a very low rate, and now it's going to execute. Now we're back into the full charge screen. It's LiPo charge. 7.639641 is our current pack voltage. This is the current charge rate. It ramps it up incrementally until it can give it whatever it can. Now, we set it to 10. On a warm day and under certain circumstances, the most you may get out of this charger for a 2S pack is about 7.5 amps on the internal power supply. Now, it's nice and cool in the shop here. One of the things they give you inside your directions, and ours is marked up, is a little table. And this table is going to show your typical maximum current rates for the charger. You're going to want to look at both sides, the DC input and the AC input. We can definitely charge at a higher rate on the DC feed than we can on the AC feed. The internal power supply is not rated for 10 amps. It's only a 7.7 volt, a 7 amp at 13.3 volts DC power supply. So it's never going to bring the full potential of the charger out. You're going to want an external power supply for that. So we'll see how far it'll go into it. You'll also see here it's currently dialed up to 5.5 amps. It's working its way up through. CC is that constant current side, so it's still in the heavy current side of the charge process. And then once it gets to about 80-85%, you're going to see that CC turn into CV. You're going to see your amperage drop way down, and then as it peaks out the voltage. The status display also shows you your current milliamperage that's been dumped into the battery. So we've fed it about 98 milliamps, or 99, almost 100, here we go, milliamps into the battery so far. So it's kind of a neat thing to watch what your capacity is and see how much you had to put back into the battery after a run. It also gives you your charge timer. Hold down your select mode button, and it's going to give you your balancing information while the charge process is taking place. Again, just like we did before, we can scroll up through and we can see it increasing our voltage to each cell. There's our high cell and our low cell. Hit it again. Right now, that's telling us where cell 1 and cell 2 are setting at. So we can actually monitor that. Hold down that button again. The select mode is going to take us back out to our charging main screen. And that's pretty much it. You've set it up and you're using it to charge a LiPo battery now with all the correct settings. Final note, never charge your batteries unattended. Always use some sort of enclosure for your batteries. There's LiPo-safe bags. Thunder Power has a couple different options out there with a small Velcro bag. They also have the larger LiPo-safe charging bags. Worst case scenario, if you're completely at the end of your budget or you're pressed for time and you don't have time to wait for something to come in or go down to your local hobby shop, go to your local hardware store and pick up a 2-cell masonry block or cinder block. You can put the charger in one half and the battery in the other. As long as it's on a concrete surface or a hard, non-flammable surface, you're completely safe for your charging process. I'm Kurt with Two Brothers Hobby. Thanks for watching.